all just voraciously curious. We all have this passionate curiosity. We're all interested in questions.
5 centuries ago, we went to explore other continents. And a century ago, we started flying. And half a century ago, we started, making rockets and going to the moon.
There's something magical and hopeful about space exploration because there's so much hope and so much potential that come with pushing the envelope.
ASU is one of the top schools in the world for doing research in planetary geology and has been for the last 30 years. It was back in 1958 that the administration really wanted to expand the research portfolio.
ASU was one of the first universities that really reached out to NASA centers and said, let's form a really productive partnership.
And since then, our School of Earth and Space Exploration, we have scientists who not only use data from planetary missions, but actually design and build instruments that fly on planetary missions.
When we think about the future of humans in space, the image that comes to mind is a NASA astronaut or it's a white-coated scientist in a lab, but in truth, it's about all of society.
Space becomes this really interesting laboratory for figuring out how do you get people to work together and how they build structures and systems that either work or don't to promote what we're trying to do in the world.
Some of the hardest challenges of human space exploration aren't technological or engineering. They're social.
We need to think about how we would manage resources in space, what human factors need to be considered, such as psychological factors.
In order to succeed in the future, we're going to have to merge technologies in an interdisciplinary way, because you have to have the will and the motivation to actually make it happen.
So the Interplanetary Initiative goes across the whole university, all disciplines, all units, all colleges. We can bring the philosophers and the social scientists and the psychologists and the people who do theater arts.
It is not standard in an academic environment to form teams at this scale.
This university accommodates that. I can form research collaborations with people working in complexity theory and engineering or robotics or evolution of cancer. We don't draw any boundary lines here.
I couldn't do the work I do at any other university because you need people to take risks on some of these big questions and you need to give them the resources to really succeed in doing those risky things. If you envision the future that you want to have, there are no limits. And you have to be brave to do that. And I think that's one of the reasons that I'm at ASU as their university explorer.
We're involved in 18 active space missions right now. We have people who build instruments here on campus that go to all the planets in our solar system and that look at the galaxies and the universe out beyond.
Much of my work right now is focused on these high-energy photons, ultraviolet light or the X-ray light from the star that blasts the atmospheres. Super flares, as we call them, happen every day on young, low-mass stars, and these are the dominant hosts of the exoplanets that we think might host life. I came to ASU to build SPARCS. That's the Star Planet Activity Research CubeSat, and it's an ultraviolet telescope housed in a CubeSat about this big. This way, you can have focused satellites doing one experiment really well.
Started working on the first Hubble results at Arizona State University in 1990. When I saw the first Hubble images, I said, gee, unbelievable. So it's like a history lesson with every lesson in the same image. The James Webb Space Telescope will look back 13.5 or 13.6 billion years back in time. When we built the Giant Magellan Telescope, we'll build it for the centuries. We'll still be doing science with that in the 2100s. So it would be like a 10-story building when it's all built, and it's this giant dish with these 7 25-feet mirrors that steer to whichever target you want to look at.
My group is focusing right now on finishing, building, and testing the new cameras for NASA's next rover. So the new cameras will be zoom cameras, and so we'll be able to go from wide-angle stereo to super telescopic stereo.
We're building an infrared camera that's going to go on a spacecraft called the Europa Clipper, and it's actually going to go to this moon, Europa, of Jupiter. That moon may have an ocean, it has an icy crust. I think in 50 years, we will have put a submarine into the ocean of Europa and really tested the question, is there life in that ocean?
There could be crazy creatures of who knows what kind swimming around in the ocean of Europa. It used to be science fiction. Now it's a reasonable scientific hypothesis.
Is it possible for life to spread? Is that a good thing if more of the universe is alive? That is what excites me, is the fact that we just don't know.
Coming from an astronomer's perspective, where we never find just one, I expect that the galaxy is teeming with life.
8.5 minutes after that firestorm starts, you're in space. I mean, the engine's cut off and it's kind of like, kabonk. And the world is different. And then you look out the window. And I remember just having this feeling of like, we belong up there.
Learning about what's happening in our solar system and beyond is really important. A lot will be discovered in the next few decades, and it'll be because of some of the systems, techniques, and capabilities that are developed here at Arizona State.
It's going to take all of the resources of the amazing diversity of skills and perspectives and experiences and cultures on our planet to put ourselves out there for real.
We're standing at the shores of a new future. We don't do this for ourselves. We do it for our grandchildren's grandchildren. And we have no idea what we will find.
We're going to space as humankind. We need to make it accessible and relatable and have a potential for everyone.
So I think that ASU has shown the willingness to do that. They have the will to succeed at it, and so altogether, I think that makes it an exceptional place.
The School of Earth and Space Exploration for us is an intellectual design project built on the notion of what we call intellectual fusion. And the notion was that we needed to move away from just scientific disciplines attempting to understand nature to move to the point of attempting to use science to power the human drive to explore. That means then we're looking to bring in whoever else is interested in that, other institutions, other people, other thought leaders, other organizations, foundations. And we want your input, we want your ideas, we want your excitement, we want all those things.